So I'm helping a church member fix their headphone now. In the process, I figured I'd document it in the event that you guys are facing the same issue. So this is for a standard tip ring sleeve. And as you can see here, what happened was they actually broke off the tip of the headphone jack. So I purchased a kit, came like a pack of 4 for like $6. And pretty much these are the parts that you see here. Now the tools that you will need is a multimeter, a wire stripping / cutting tool, as well as a AA battery. Doesn't need to be fully charged, but still should have sufficient voltage on it. And last but not least, you're going to need a soldering iron as well. Now the first thing you'll want to do is try to determine the pinout of the headphone cable, because it can vary. Now again, this is for a Vic Firth headphones. Different manufacturers can vary to create a proprietary connection, but typically the standard is overwhelmingly the tip is for the left channel, the ring after that is for the right channel, and then last but not least, the last rung is for the sleeve or the ground cable. And that's represented by this replacement part whereby the tip goes to the left plug here, the ring for the right channel goes on the right side here, and then last but not least is the sleeve for the ground. Normally, the manufacturer of your replacement part should provide you with the pinout, but just in case, you could find that out using a multimeter as well. First thing you want to do is set your multimeter to the continuity test with the signal. It makes it a lot easier. Simply take either side of the cable, put it on just solely the tip, and then touch one of the 3 prongs. So I've determined that this pinout on the left here is in fact the tip, which should be the left channel. Next up is to find the corresponding end for the ring. And this is a little tricky because you're touching 2 round surfaces together, but so I've confirmed that that is in fact the right channel or the ring. Then last but not least is the ground. So that's the last rung here. Touched it to the ground there. So thereby you've confirmed the pinout for your replacement part. Now you want to do the same for the headphone cable as well. So I've confirmed on the headphone side that the tip is in fact the left channel, because giving a quick listen, I'm only getting audio on the right channel. The problem is that once you cut this cable, you may not know which wire corresponds to which channel. So I'll teach you how to do that in a second. So the first thing you're going to want to do is just simply to cut this off. Normally I would recommend doing it right at the very end so you preserve as much of this length of the cable, but perhaps, I don't know. Maybe you've always found that the cable wire was a little too long, so now you could take this opportunity to customize it to the length that you would want. But for this video, I'm just simply going to cut it right at the very end here. After cutting off the O jack, you want to take the base sleeve and route it through. Make sure that it's in the right direction with the main opening with the threads for the jack here, and just route that far away from your work area. They've also included some heat shrink tubing, although there's going to be very little space for that, so I'm not even going to attempt the smaller one. But the big one that goes around this cable, you should cut that to length. So the idea is that you would probably cut it just a little past the base of the sleeve here. So find that measurement, grab a pair of scissors, and then just give it a quick eyeball to determine the length. Now the reason why I would use this is to help with the relief strain of the wires and to just keep everything tidy together. Now you'll want to strip the outer cable coating as well as the individual wires within, and likewise with the heat shrink tubing, just do a quick measurement. You don't want to strip off too much because you want to ensure again that this outer coating remains below the shell. So that's a pretty good length to aim for, because you're going to need to strip off each of these individual, route it through the tiny holes here, and then solder them in. Now, in terms of determining the correct polarity, what would really help is if you had some spare cables around, or better yet, some alligator clipping and that AA battery. So next step is to strip off each of these individual cables. How you approach this is up to you. If you want to take a scissor, just go very gently around the edge, or use your fingernails if you have any, and just go ahead and just scrape off a portion of the coating. It is fairly thin, so you do have to be careful with it. So there you can see I've already exposed the red cable. Wash and repeat for the others. What may help is if you had a scissor, just give it a very tiny little score so that you expose it, and then use your fingernail and just pull off the rest, the insulation. I actually forgot a step. Before you even strip those, you should have routed the heat shrink tubing that you cut earlier, and just make sure that this is routed as far away from the end of the cable as possible. The reason being that as you're soldering these wires, you don't want to inadvertently shrink that heat shrink tubing in the process. So now that all of these cables are exposed, as mentioned, what would be helpful is if you had the alligator clips. The reason being you want to try to figure out which is the left, which is the right wire. Now with the alligator clip on, the red to red, black to black, you're going to connect one end to the battery, and the other end you're just going to very briefly touch the other side of the battery. The reason that you will hear a slight static sound as you make contact, and that way you could tell which is which. If upon the first brush both sides of the headphone make a sound, then that means you got both the left and the right connected. Then you simply will disconnect one cable, go to the other, and test it individually. Then that way you can make the distinction between the left and the right side. So right now I can see that the black is the ground, the red is the right, because as I do this, I hear the static only on the right side. And just to confirm, I am now going to disconnect the right cable and connect it to the white, and I should now hear sound only on the left side. Yep, and that is confirmed. So now I know that the black is the ground, white is the left, and the red is the right. So now you're going to get ready to solder all the wires onto the jack. What might be helpful is you've kept a sheet. This got exaggerated when I printed it out, but whatever. The point is you don't want to make a mistake here and then have to redo everything or inadvertently flip the channels or the cables around. Now, first thing you want to do is with all the exposed wires, just simply bind them up and tighten them up. Now you definitely want those tips as wound as tight as possible because you're basically going to be threading them through the tiny holes on the jack. A tweezer could come in very handy here to help get that cable through the hole. Once you thread one through, you're going to basically twist it around and just take your time because very delicate process here. So once you have all three routed through, you want to take the base and plant it against the sleeve here to kind of clamp it in. That'll help stabilize it before you solder. Next, you're going to wind each cable around the base of those solder tabs and just ensuring that they are nice and neat and that they do not cross-touch each other. And that pretty much does it. Just give it the final once over, ensuring that none of those wires are sticking out or cross-touching another one of these tabs that it shouldn't, and you're pretty much ready to solder now. At this point, before proceeding any further, you might just want to give it a quick test. Just grab it very carefully by the threads. Beautiful, it is working. Now, as you're extracting it, make sure again, grip it tightly by the thread and pull it out gently. So that way we now have confidence to proceed with the soldering. It'd also be very helpful if you had a clamp to aid you. You could get creative if you don't have something like this, maybe using hairpins or whatnot. But bottom line is that get someone or even an assistant to help you hold on to this as you're soldering. Now, before you proceed, I can't emphasize this enough. There is plastic in the core here. If you hold the solder against this too long, you can potentially melt or deform the plastic in here. So you have to be very quick about this. Try to stay as far away from the tip as possible while aiming directly at the cables to be soldered. With the black cable done, we're going to target the red one now. And the idea is to heat both the cable itself as well as the solder base, the tab, so that way that solder will seep into both. And last but not least, the white cable. Again, just work very quickly and deliberately because this one will be the most sensitive given its shorter tab and proximity to the center and the whole plastic. Give it a once over, again ensuring that there's no wires sticking out or touching any tabs that they shouldn't be. And then the last step would be to clamp this cable here, get the heat shrink tubing on, and then the base tightened up as well. I'm reasonably sure there's a dedicated clamping tool for this, but since I don't have it, I'm just going to use a typical wrench. Or again, find whatever you have, maybe it's a plumbing wrench or whatnot, but you're going to just basically squeeze this tight together. And the idea is to get it towards the middle. Well, it's not quite what I wanted. I wanted it to actually cave in to attach to each other, but like I said, it's the best I can do with the tools that I have. Now, last but not least is to get the heat shrink tubing over all of this. To be honest with you, it's not so much for insulating the cable as it is to really tightening that clamp here. Once it's in place, just grab a lighter and go ahead and keep it at a distance, rolling slowly until you see it shrinking on. Double check it and make sure again that this part is actually as tight as possible, because again, you want the whole thing to be reasonably tight so it keeps that clamping force on the cable. So I actually do see some slack there. I'm going to go ahead and give it another go. First, let it cool off. And once it's cool to the touch, go ahead and simply screw on this base. This step is optional, but if you want to, go ahead and increase that clamping force. Add a little tissue to protect the jack itself. Give it another quick go, but don't go overboard because this plastic is actually very light. Now, one thing is that he does have a young boy in his household, so because of that, I will probably add a dab of super glue here to help enable it, because most likely a lot of the times they just simply yank it out from the cable itself as opposed to the jack itself. And that wraps up this video. Thanks again for watching.